Hello and welcome to this interview episode of the Primary Maths Podcast, the show where we talk all things primary maths. I'm Jon Cripwell. Language sits at the heart of mathematics, but do we always stop to notice how it shapes what pupils understand, how they think, and whether their thinking ever becomes visible to us as teachers? In today's episode, I'm joined by my guest as we explore the relationship between language and mathematical thinking. Across the episode, we talk about why mathematical thinking so often remains invisible, the many ways pupils communicate their ideas beyond written work, and the risks of moving too quickly to tidy up language before we've truly listened to what it means. My guest today is Dr Kate Quade, and I am delighted to have her on the show. Welcome, Kate.
Hello, hi.
You're joining us from Australia. So when we're recording this, it is 8:30 in the morning UK time in January. And we were just discussing actually, as we do, the differences in weather and climate and things. So you were saying, Kate, it's been 40 odd degrees over there last week in Adelaide.
Yes, indeed.
Yeah.
Yes, we had a nice
And
big wave.
I've been looking out the window at snow here in the UK, but some things don't change wherever you are in the world, and hopefully we're going to find some common ground on education and maths teaching and maths language, particularly this morning. But Kate, it's always interesting for myself and for the listeners just to have a little bit of an introduction to yourself, what you're doing currently, how you sort of ended up doing that, if that's okay.
Yeah, thanks, John. So I started as a primary school teacher here in Australia. Went straight from school into university, did my teaching degree, and had a lot of different experiences in that teaching degree. Trying to get a permanent job was quite challenging, so I did lots of casual work. And that's always an interest in that casual sort of short-term contract work. And then I'm old enough to have jobs in the paper. So there was a nice job in the paper that was advertised as working at our National Science Centre. So we just got Questacon, and that's in Canberra. And because I was actually living on the East Coast then. And so I applied for this job. Part of it was doing a role play. I was unsuccessful in that job. This was around a science communicator. But the next day I got a call to say, we would love to employ you as the maths coordinator of the Maths Centre, which actually had 500 puzzles, and I travelled around the country with that job. So I had some really interesting experiences with that, and that sort of led to other experiences. And then I went for a continuing position in the Australian Capital Territory and was successful in getting that. And so then moved around the country a little bit. I've taught in New South Wales, the ACT, Queensland, and it was actually 9 years ago when I moved to South Australia that I started a PhD that examined young children's attitudes towards mathematics, and now I see myself as a researcher and teacher at the university level.
Fantastic. So a wealth of experience to bring to this morning. So tell me about the puzzles that you used to work with. What sort of things did that involve?
So they were actually physical, we called them puzzles, and I suppose this was in the 2000s, so I'm showing my age, but back in the 2000s, we had physical boards that children could manipulate different activities. There was number puzzles, logic puzzles, shape measurement puzzles. They range from about year 3 to year 10. We would then take them out to regional areas. So I went out to, I'm not sure if you're familiar with the geography of Australia, but as far north and west as Mount Isa, and then all the way down south to Shepparton, and in between. Got to see a lot of Australia, and which was wonderful. And we invited children from the local schools or nearby schools. So some children and schools would sort of travel several hours just to come to this travelling maths centre. And they'd stay for about an hour and a half, engage in the puzzles. I had a co-presenter, and the co-presenter and I would sort of madly run around changing puzzles, ask children how they were doing the puzzles, about their mathematical thinking. And then we'd sort of do this sort of recap of a math interesting fact. So
Yeah, I think
sort of influenced the way that I teach math today.
yeah, I think puzzles are such a fantastic way to engage people of all ages really in maths, and sometimes it's one of the ways that we end up doing maths without really recognizing that we are. I remember when I did a qualification called the MAST, the MAST course in the UK, which isn't around anymore, I don't think, sadly, but it was basically a math specialist teacher
Mm.
qualification, sort of master's level. But part of that, we went on a residential. And on the first night of the residential, they'd set up these puzzles all around the room, and you sort of you were given a sheet, answer sheet on, and you went around and you just had a go at all these different puzzles. And although we were there obviously as maths specialists, we sort of knew that maths was involved. It didn't feel like doing maths at the time. I just think puzzles are an underrated way, especially physical ones, of engaging children in maths and getting that mathematical thinking. So I'm always interested to hear more about puzzles and things, which is wonderful. And some of the conversation that you hear around puzzles and things, when children are engaging with that, is particularly insightful, I think. So I'm interested to unpick that a little bit more in a moment if I can. You sort of went towards science originally, then, Kate, and then
Yes, I
for that
suppose.
position.
Yeah, as a generalist primary teacher, when you do your degree, you specialise in all subjects. So there wasn't a typically math specialism, although we could choose electives, and I recall choosing electives at the university level that had a math focus. And I
Yeah,
suppose for me, there's always no harm in trying different things. And so when I saw the job in the paper, I was like, there's no harm in trying. They wanted a qualified teacher. They wanted someone with some teaching experience. And there was having someone to travel for up to 10 weeks of a year and being away from
yes,
home. And I went,
yeah,
yeah, I can do all that. And I was successful to get an interview, which was exciting. But so yeah, this initial position was a science communicator. And at that point in time, they wanted me to communicate about fiber optics, which I knew about
right,
much about.
yeah,
Um,
yes,
and and did some research. I actually dressed up as a doctor in the interview, had a stethoscope, and said that I was going to do like a laparoscopy and how, sorry, an endoscopy, and how those instruments actually use fiber optics. So I was really not speaking very confidently at all about the job, but I suppose there was something there that they could see that I could um, relate and
yeah,
be useful in the
yeah.
maths centre.
That makes sense. So did you enjoy maths at school when you were at school yourself? Was it one of your favourite subjects, or was it not up
Yes
there?
and no. Can I say yes and
Mhm.
no?
Yeah, of course you can.
Um,
Yeah,
I suppose if I look back at my early primary career, primary schooling experience, I was a quiet, reserved student who probably wouldn't say boo to anyone. I wasn't the one that put my hand up to volunteer answers. I was very a quiet, I suppose you would call them a reluctant learner.
yeah,
And so I suppose that might have been due to the way that maths was structured. It was always an individual pursuit. You sort of were given sets of tasks. I remember having um, boxes with cards in them, and you put out a card and you did a problem, and then you check the back of, or you got a different card to check the answer, and you put it back in the box, or
yeah. That sounds
you.
very, very similar to my experience of primary maths at school. Yeah,
Yeah, or we had this thing called a tutor system where you had these books and they were basically mathematical sort of or very closed answered questions. You answer the questions and then you had this tile system that I think would have had about 24 tiles. And on one side of the tile had a number and on the other side had a a a picture of a part of a shape. And so you had to put these numbers in order. And then once you got your answers, you closed the tutor system and you flipped it. And then if it made the pattern, you knew you got all those questions correct. So I
wow, I've
remember
never
sort of
heard that
using,
before. Okay,
yeah, I think it was an Australian resource, probably early 80s,
right,
maybe late 70s that it came out. Um, so I remember using those kinds of things. And I suppose what I liked about the tutor system was actually creating patterns and things like that. I
yeah,
probably fudged the answers sometimes of looking at, well, can I make the pattern rather than just answer the question?
yeah,
Um, and so then I could start to see, could see how manipulators were used. And I actually loved using manipulators at a primary school student. I remember using like the Cuisenet rods,
yeah,
the Montessori resource, where like yellow was like worth 5, and then I think red's worth 2, and making and using that resource to engage in a whole lot of mathematics. So for me, that I suppose sparked my interest as a kid and going, oh, I really like doing this. But I did change schools 3 times within a year, just to family circumstances. And at my second school, it was drill and practice. I recall um, sort of stating your times tables facts over and over and again. And each morning you would, as a class, cite your times table, whatever it might be for the week, 6. And at the end of the week, if you did very well at the test, you got this little green certificate with a little monster in the corner that says, I know my 6 times tables. And you all were trying to get this little certificate. So I suppose parts of it 100% enjoyed. Other parts you just go, could leave it. But yeah, a varied experience.
And and I think that's reflective of lots of people's experience of maths at school. You know, bits that we liked, bits that we didn't like so much. As regular listeners will know, I was no fan of maths at school at all, and was terrified of teaching it when I became a teacher, actually. But now it's obviously my favourite subject and the way that I spend all my time really thinking about maths. But again, if you'd have told me that when I was 18, leaving education to go to university and things, I would have laughed at you and ran away, I think. So yeah, it's interesting how, you know, different experiences can shape things over time, and finding the right way into understanding the maths, I think, can, you know, and for you, obviously, using the manipulatives had a particular impact. And I think through teaching, I've seen how manipulatives can really open up maths for lots of children. So now, as you say, you spend your time as a researcher. Primarily in maths education, Kate, or in just education generally?
No, purely in mathematics education. So different aspects of math education, but just math education research.
Fantastic. And one of the articles that the papers that you wrote that I first came across your work actually was around language and mathematical thinking, and the particular phrase, which I know you didn't coin, but porridge words sort of jumped out at me. I hadn't come across it before, and I thought it was interesting. And I did share on the podcast, I shared that we have a Friday episode of the podcast where it's myself and the co-host Becky, and we talk about things that we've noticed and seen and things. And I shared this particular piece of research with listeners at the time, and then thought I really ought to talk to Kate about it because it's beyond my expertise and very much in your wheelhouse. So would you mind just giving me a little, or giving us all a little bit of an introduction to what that work was around? What led you to look at that particular area of focus, and what did you find out?
Sure. I suppose I just didn't wake up one day thinking, oh, I'm going to describe mathematical thinking using this idea of porridge words. But
Yeah.
for me, my research, my teaching experience, and my interests are strongly connected and interrelated. I can't necessarily separate them. So I suppose reflecting back when I was teaching in the classroom of encountering kids who would come up to you when you ask them a question of how did you do that? And they might just say, I don't know, I just did it in my head. And that phrase has always stuck with me of, well, I want to know what's actually going on in your head. How have you got that answer? I can see evidence that you've done some mathematical thinking. You've given me an answer. It might be the answer that I was anticipating, or it could be an answer that I wasn't anticipating. But either way, I'm still curious about how you get from I did it in my head to the answer that you shared. So I suppose there
Yeah,
was
I think
that
every teacher's come across that situation, haven't they? Where, you know, we can see whether the answer's right or wrong. We just want to unpick a little bit about how you've got there. And some children are really good at doing that, aren't they? And they can really clearly show you how they've done that. And others really struggle with it. Sometimes particularly what we might class as the high retaining or more able, in inverted commas, pupils find it quite difficult sometimes to articulate that.
Yeah, would agree. And so there could be, as you're saying, multiple reasons why a child might say, I don't know, or I just did it in my head. And it might be as a strategy to say, go away. I don't want you to ask me any questions. And so it might be
Yeah.
deflecting attention from them. They may not have the confidence or in sharing in general. Like, I was not a person to put my hand up when I was at primary school. If you asked me, I probably would have mumbled something and as my way of saying, don't ask me. Um, they might not be confident in the language or the actual concept. So they're just saying, I don't know, I just did it in my head. Or they just may not just be willing to share for a whole variety of reasons. So I think understanding the reasons also helps me. So that's where I was like, going, there's often a reason. Can we try and unpack what this I did it in my head looks like? And so I suppose for me, then research, similar to mathematics, is like it's about noticing patterns and describing those patterns. So I started to do a research project around this wondering, and I did some research in a small school. So when I say small, I mean about 36 kids, so about 2 classes. Yep.
Oh,
Uh,
was that primary or
it was a
infant or
primary school, so yeah,
okay.
we call it the first year reception
Yeah.
in South Australia, but we have different names across Australia. So it could be foundation, it could be kindergarten, it could be prep. But that first formal school year through to year 6. So there was 2 classes. There was an R to 2 class and a 3 to 6 class, and wanted to see how students were communicating their mathematical thinking. And this sort of research started to coincide with the work of Peter Lillingholt, who came up with building thinking classrooms in mathematics. And that book sort of described the pedagogy of building those thinking classrooms. And so I had this data, and I could see the pedagogy of having and strategies to develop students' mathematical thinking. But one of the questions that remain unanswered is, how do students communicate their mathematical thinking, and what language do they use? So I suppose there was some reflection, and I had this rich data, but not a great way of describing the data. And so I stood one day in front of my bookshelf, and I was like going, I know I've got some books around thinking. I know I have this. And so my eyes sort of went to Edward de Bono's book. And I recall Edward de Bono from my early teaching around 6 thinking hats, and the different coloured
Yeah.
hats coinciding with different styles of thinking. And next to that, I had the book, Edward de Bono, Practical Thinking. And I was like, and I pulled it off the shelf and I started to read, and it's Edward de Bono, Practical Thinking from 1972, that actually used the word porridge word. So I can share more about that.
Yeah, absolutely. Yeah, I think it might be useful to just what uh, in England particularly, when I was doing my teaching practice, which was about 16, 17 years ago now, thinking hats were very much something that had come in to kind of. We know how education can sometimes go in this sort of cyclical nature, can't it? And there's, I don't want to say, there's things that are popular and then they sort of fall off a little bit and something else comes in. And thinking hats and thinking glasses, actually, I seem to remember, had very much been in, and they seem to have dissipated a little bit now. I very rarely see that sort of overt representation of those principles, but I think a lot of those principles are still sort of evident in practice, just maybe not kind of actually having hats or glasses and things. For anybody who isn't familiar with that, do you want to just give a quick, if you can, Kate, a very quick sort of overview of what that work was about, and then uh, the practical thinking side and the porridge words that come from that? Is that okay?
Yeah, definitely. So Edward de Bono used the word or the phrase porridge words to describe ambiguous terms that that we use to try and keep our thinking going. So I'm just going to read a little bit from his book because it sort of just sums up a bit about it. It's a couple of sentences. So from page 24, Edward de Bono says, porridge words indicate definite ideas, but when you get to examine the ideas, you find that, like porridge, they have no form, no shape, and there is no definite meaning that can be grasped. So I suppose he's really referring to, in general, words that we sometimes use as filler words. Sometimes they are vague, sometimes they're ambiguous, sometimes they're close but not close enough. And I have like an example of the Scarecrow from The Wizard of Oz when he finally gets his brain and he's seen citing the Pythagorean's theorem, and he uses the word isosceles triangle. Now, if he paused and said, "Oh no, isosceles is not the right word," and tries to find the word, then his thinking would be interrupted. It might stop, and he might go, "No, I give up. I'm not going to continue communicating my thought." So I suppose in that sense, the word isosceles that the Scarecrow used could be seen as a porridge word, as a way to facilitate and keep thinking moving.
Okay, so in maths education, again, I'm going to reference this to sort of my experience, which is the English system. For the last few years, we have had quite a focus on language and oracy, however you want to pronounce it. I'll keep arguing with people about that. And we've introduced some what to many people would be new language around maths, things like minuend and subtrahend to describe particular parts of a subtraction algorithm and things. We're not talking about those specific words, are we? We're talking about maybe some thinking that comes before that, or not? Am I getting the wrong end of the stick here? Okay.
No, I think both. So Edward de Bono just classified these vague, ambiguous words as porridge words. And I suppose what my research examined was trying to classify some of these words so that we have a better understanding of how they're used in mathematics. So it could be as a generic sense. So a child might say something like, I was doing some math today. They can't elaborate what math, or I was doing math on the iPad. They can't give examples or elaborate or unpack it. So it might be a generic sense. It could be a conceptual sense. So some of the common porridge words that was evident in the research with words like sums. So I was doing my sums, and then the child then proceeds to say, I did 16 times 4. And so the word sums was a catch-all generic phrase for any of the basic operations.
Yeah, we hear a lot of adults still referring to any calculation as being a sum. I'm doing these sums. And yeah, as you say, that sums in maths obviously refers to addition, particularly, and finding totals through additive relationships. But yeah, as you say, it can be a catch-all, can't it? It can refer to
Yes.
everything in sort of everyday language, I suppose.
Yeah. Exactly. And there was a whole lot of other examples around using the word diameter. They tried to use diameter, but then referenced a rectangle. So just like a mismatch between the level of accuracy in terms of what we would anticipate that word to be and how a child and sometimes a teacher was using those words. The other categorization was around a procedural way of using the porridge words. So sometimes kids struggle to communicate the procedures, and they might just say, I figured it out. And that seems to be quite a common phrase at the moment of I figured it out, but they want to unpack the process around that. Or a child gave an example of a 2-digit number times another 2-digit number and said, oh, then I popped them over into. So when they were sort of moving from the ones column to the tens column, I popped the number over and into. And so there was a vagueness of the procedure. So the language was not yet developed in that. And sometimes as we've sort of started the podcast around that, a category could be just invisible thinking, that we just don't know what a student is thinking. They haven't shared how they communicate in their thinking, so their thinking remains invisible.
Okay, so I can sort of see that as well, I was going to say I could see it as a stage or a step within developing that thinking structure. But as we've already said, sometimes that can remain, and we have adults that are still saying sums, for example, to relate to all sorts of procedures. So are porridge words? What does it mean, Kate, for the teacher, the educator in the room? Are porridge words a problem, or are they something that we should be looking at and recognizing as thinking? What's your take on it?
Yeah, I don't see porridge words as a problem whatsoever. If they remain undressed, they could be, but to me, they're signs that children are thinking, or that the teacher is thinking, or that we're communicating our thoughts with the best language that we possibly have at that time. So for me, it's a opportunity to learn new language, acquire those new mathematical terms. So to me, I don't see it as a problem. It's recognizing that thinking has occurred in that verbal sense.
Excellent. Okay, so if I'm hearing children using words incorrectly, obviously that's I want to address at some point, don't I, the fact that that's not the correct language, but at the same time, I need to be recognizing that actually it may be the wrong word, but it's evidence of the way that they're thinking about the maths and the connections that they're making within it. Is that right?
That's right. Yeah.
Excellent. So I can use that from a sort of formative assessment point of view to think, okay, I know where this child is, even though they're not using the correct language. Is it important that we move towards the correct language then, or is it okay to continue allowing children to express themselves in whatever way they want to?
Yeah, I think there is a goal around using correct mathematical language. And I think if we look at our curriculum documents, they often model the kinds of language that is expected at a particular year level. So they're modeling the kind of language. I think it is important to have that common language. And I want to just give an example of a child who might change schools or change classes in the next
Yeah.
year, and you might have developed colloquial or classroom language about a particular thing, and then that child changes their learning environment or a different class. There could be a disjoint. So in some of the research that I've collected, I had a year 2 child who was reflecting back on her experience when she was in reception, and she was saying that she didn't really enjoy mathematics because she didn't know what a tens frame was. And now, for context, hoping that's a common
Yeah.
language in
Yeah.
Australia and the UK, but it's basically a table of 2 rows with 5 columns that you can arrange things, and basically there's 10 squares. Great um, model for using addition, subtraction, all kinds of things. But she didn't know what that tens frame was. So when the teacher was in year 2 was starting to talk about this tens frame, she just was lost and started to disengage. So I suppose if we are not using the correct language, we run the risk of children disengaging in our mathematical classes or
Yeah.
any of our classes. And then that can then have long-term implications to their future engagement.
Yeah, it's interesting, isn't it? I've for a little while now, I've been thinking about representations and how we can try and move towards a more cohesive um, journey through representations across school. I mean, initially across school itself, just one school, that would be helpful. And I think we've moved towards that certainly in England over the last few years because of the introduction of schemes and things like that. Still not perfect. And as you say, sometimes a child can move from one class to another class and there's different language, there's different representations. And so sometimes as a teacher, that drive for consistency can feel a bit pedantic, a bit restrictive, a bit, as if our autonomy as a teacher is being eroded a little bit. But actually, when you recognise the reason for it, it's really important, isn't it, that there is a consistent approach to help pupils within a school. And then, as you say, moving between schools in different areas of the country, even, or even within the same city, just a
Mm,
couple of miles apart, maybe, can have a huge impact because if you've got to relearn some of those concepts through a different lens, even though they may be familiar in one context, that can be a barrier.
definitely. And so I suppose it does speak to that importance of having that common language, but using language within the correct context with a level of accuracy. And the language can vary depending on the year group, depending on your class, and that it might be a slow introduction to the correct mathematical terms. But I suppose
Yeah.
it speaks to the importance of having that common language.
What's your feeling, Kate, on the age and stage at which correct language, correct mathematical language should be introduced? So, for instance, the first year in education in England is also called reception, as it is in Adelaide, by the sounds of things. So those would be 4 and 5-year-old children coming into reception. Um, at what is it appropriate to use correct mathematical language with them, or should we be using, or porridge words fine at that point? I mean, I've got my own opinion on this, obviously, but I'd be interested to hear yours.
Yeah, I'm sounding like I'm going to sit on the fence. Both. Once again, yeah, correct language is important. So, in in Australia, our curriculum talks about subitizing or subitizing, depends on
Yes.
how you
Yeah.
want to pronounce it. I say subitizing, so I'm going to stick with that.
No, I'm with you. I'm with
Okay,
subsidizing as well. That's great. That's definitive now. We've
cool.
agreed it
Okay,
across continents around the world. Subsidizing, perfect. Yeah.
excellent. So they talk about subitizing, and I remember when my eldest child was in reception and she came home and I said, and as a good parent driving home, what did you do today? And trying to probe what your kids are doing.
Yeah.
And she said, I was sabotaging. And I just had this blank look and I'm like going, that's not a word that I'm familiar with. And then I realized, oh,
Do
it
you
just
mean
means like,
subtract? You were subtracting? Yeah, yeah. I had similar, experiences. Yeah,
yeah, but my daughter, who started school at the age of 4.5, was very familiar and confident in using that term. So obviously, the teacher had modelled the term, had modelled how to use it, modelled the process of subsidising, of quickly recognising a collection of objects up to 5, so that they could actually do it. So it actually then helped talking about this process. So sometimes one word can succinctly describe a very complex idea. So, yes, I think introducing the language, there is no age requirements of language. It's whatever uh, the the language that the child can cope with, and it does come down to knowing your students and knowing how they learn, and so what they're able to retain and use. And sometimes it might be actually they might not be ready for the word sabotaging as an example, and you need to describe the process, and you might go, gosh, that explanation is really long. Is there a word to describe that
yeah.
process? Yes, there is, and I might introduce it that way. So whether you introduce a word first or the process first or the word or the concept first, I don't think there is a correct order. It all depends on knowing your students and knowing them well.
I think it's to my mind, a balanced approach, as you say, is important because you want to introduce the word, but also the meaning of the word, don't you? And in order to explain the meaning of the word, you need to use these porridge words often. I
Yes.
think to actually convey meaning alongside representations and manipulatives and all the other things that we would expect in good teaching. My go-to sort of analogy with words like subitizing is that in phonics for many years we've had absolutely no issues with introducing children to graphemes and digraphs and trigraphs and things like that. At whatever age you are, new language is new language, isn't it? And children, particularly young children, absorb language like a sponge in many cases. And in my experience working with schools and in schools, sometimes it can be the adults that have a harder job actually using new vocabulary, understandably, because you may have lived for 40, 50, 60 years with particular words. In fact, I was having a conversation with my mum last night, who was in her 70s, and she said that she'd been talking to her partner, and he said that he couldn't do maths anymore because it's all changed. And I rolled my eyes as I was driving down the road and said, "No, it's not all changed, but yes, there are some new different terms that you might be less familiar with." In fact, her point of reference for maths having all changed was order of operations and BODMAS, BIDMAS, PEDMAS, whatever you want to call it. And I sort of said that's been around for a very a very long time, definitely when you were at school, but maybe it wasn't referred to in that way. So is there benefit, do you think, Kate, in explaining this sort of thinking to educators, to teaching assistants, teachers, adults in schools, to help them to understand why porridge words are useful and should be recognised, but also why the correct language is also useful and not something to be scared of?
Yeah, definitely. So I think so I work at Adelaide University. We do a lot of teacher preparation programs. There's a place there in teacher education preparation programs, but it's also in place for in-service teachers, those teachers who are already teaching in schools, so of understanding that the importance of mathematical language. And whether you call them porridge words or not, I suppose that's besides the point. But I suppose I was trying to give that meta language to something that's actually a really important aspect in mathematics around communicating our thinking, communicating our explanations, and being consistent in the language, in a particular term that we use, but not being afraid, as you said, of using terms. And sometimes it's a teacher who goes, I don't know that term, so I'm going to try and describe it in many multiple ways.
Yeah.
I have one example I'll just quickly share of
Oh.
I saw a teacher explain how the conventions of naming an angle. So you have two rays joined at a point. It's really hard not to use the correct language, but anyway,
Yeah.
I'm going to model what he said. And so often when we have those two rays at a particular point, we use an arc to join those two rays. And so he was saying to name the circly bit, we can put a letter and we use that letter to name it. And I'm like going, at first I
Well,
had no idea what this circly bit is, but I
yeah.
could see how he was actually referring to this, that circly bit was like a sector of a circle, but what he
Yes.
really meant was the word vertex. And so I suppose it is really important that as teachers and as educators that we know the language so that we can model it in good practice, and so that children then can pick up on that language and use it, because we ask students to use this language when they engage in assessments.
Yeah. Yeah, I totally agree. And I've sat in lessons with with similar frustrations, I think, with, that there is a word that we could use that would explain this. Also, just reflecting as you were talking there, Kate, that the term porridge word in itself is a useful label, isn't it, for something which is slightly amorphous and potentially difficult to describe. That's I kind of like that. It's I like how it's become, potentially could become the actual correct label for something to help describe it.
Yes.
So all of this is linked to, as you've said, mathematical thinking. And we recognise the importance of mathematical thinking. Again, in England, the National Centre for the Excellence in Teaching Maths has these 5 big ideas for teaching maths. And one of those 5 big ideas that should be the focus of not necessarily every lesson, but although I would argue in this particular case it should be every lesson, but should form part of your sort of pedagogical approach. And mathematical thinking is one of those things. And it's very difficult to think mathematically, isn't it, without language? Would you be able to, I know this is an area that you've sort of researched and have interest in, would you be able to just explain that sort of link between language and mathematical thinking? Is that okay?
Yeah, definitely. So I suppose mathematical thinking is often invisible because it is something that we just do ourselves. It stays in our head. A lot of researchers have tried to describe what mathematical thinking is. And I recall Anna Savard, who describes mathematical thinking as a self-communication process. But when we require students to, when we need to assess students, we need them to communicate their mathematical thinking. And so often their mathematical thinking is either verbal or written. And I suppose they're the two primary methods that we emphasize in education. This video is full of gestures. I can't help but gesture. So we often dismiss gestures as a form of communicating their mathematical thinking. Sometimes we might use a gesture to try and help us communicate thinking. But we could also use other means. I'm happy to sort of unpack some of them if you'd like.
Yeah, if you've got time, Kate, I think mathematical thinking is fascinating because it's one of the things that, as I've said, we've talked a lot about the importance of it, and we need to make sure that children are thinking mathematically, and we want to model that. So we a lot of the pedagogical work that we've done recently has been around modeling representations and thinking aloud and that idea of metacognition and that sort of thing. But I'm not sure that we've ever really articulated quite what, and as you say, lots of people have grappled with what mathematical thinking really is, but also the different ways that it can be expressed. So I think that would be useful if that's okay.
Yeah, definitely. So we've got the verbal, and I think that's a tried and tested. We might ask students in the moment, around how to explain their mathematical thinking. We've got the written, but if we start to categorize some of those written forms, we could have things like symbols, pronumerals. They're all ways of communicating our mathematical thinking. So if we're using the correct operation in a particular question, we could have graphical means. So communicating our thinking through graphs or data displays. We could have other pictorial representations, so pictorial representations that a child draws at that. So you might be in a graphing task, and students have to produce a column graph. They might have created that using manipulatives. That's a form of communication of their thinking. But then you might get students to trace around the manipulatives, and then they've got a graphical representation. This is evidence of their communication, of their thinking process. So you could have that pictorial display. But some of the overlooked ones include gestures. Big fan of gestures. The role of play. So sometimes when we're playing with ideas, and I suppose this always comes back to my experience working at the National Science Centre, and
Yeah.
playing with puzzles, or what we'd probably call now is rich tasks or challenging tasks, but playing with different ideas and playing with strategies, or working out, can I actually solve this particular problem by acting it out or creating a model, or can I create a table, or whatever strategy you might be thinking about. We often overlook the use of technology when we communicating our thinking. So, and I'm not just talking about Word or a PowerPoint, but there's different educational technologies, so calculators and different kinds of apps that we might use. I think I've covered them all. And of course, there's that invisible thinking that still remains invisible to others. So I suppose think I've counted 10 ways that we can start to
Yeah,
communicate our
yeah.
thinking.
Uh, that's fascinating. Thank you. Is there? I know this might be again. It's a question I've probably got my own opinions on, but is there a form of articulating or verbal or expressing a mathematical thinking that is better than the others? That is indicative of somebody who is a better mathematician than another people.
I would say no. I know the education system emphasize written. You think
Hmm.
about all the assessments, the end of term tests, or if you do tests, or even an investigation, it's often written. So the education system seems to emphasize a written form of communication, and I suppose it's known, it's familiar, it's usually accessible to many. So that's probably why they've just gone to that written version. We then sort of started to bring in oral explanations, or a video that does a verbal explanation. So we emphasize those two, but we often overlook all the other types of modes of communication. And actually, they do have value. And if we're wanting to have mathematical learning experiences that are accessible and inclusive, we do need to start to think about a range of ways that children and adults can communicate their mathematical thinking. So,
Yeah.
no, I would say manipulatives are a great tool that can facilitate that mathematical thinking. You can often see children use manipulatives to model something, and then they use that to launch their verbal explanation. So, I wouldn't say one's better than the other. Sometimes they're linked, and they help to get to what we would in education probably have a stronger emphasis on in terms of that written or verbal. But to me, they're is equally important.
No, I completely agree. And I worry sometimes that as you say, the system that we have in education, and I understand why the system is the way
Yep,
that it is, because you're standardizing
yep,
testing essentially and curriculum across thousands of schools. However, when I've worked with children in reception or year one, so some of our youngest pupils, some of their thinking that you can see through uh, the stories that they've drawn is fantastic and real clear evidence of mathematical thinking. I'm thinking of a particular example, actually a fairly famous example, certainly here, of a rhyme about five little monkeys sitting in the tree. One fell out, and you can see different ways that children had um, drawn and represented that story. And some have done it quite abstract, and others had done it actually drawing the monkey sitting in the trees. And all of them, to me, were absolutely representative of clear mathematical thinking. And I do worry that sometimes when we push a particular form of here's the correct way of expressing that, we really risk some pupils feeling that they can't do it in that particular way, and therefore feel like they're not being successful in terms of mathematics. So yeah, I totally agree, Kate, and I think it's really important that we take every opportunity to, provide different ways of expressing mathematical thinking and recording mathematical thinking, because we do want to see it. And as you say, sometimes it can be really hard to see it, and for children to verbalise it. So all those different ways are fantastic. Thank you very much. I'm conscious of time, and I could honestly talk to you all evening in your case, or morning, all day over here. I don't want to keep you any longer. Was there anything else that you wanted to share, Kate, or are we happy to wrap it up at that point?
I suppose the only thing that I'd like to finish on, John, is that what happens if we dismiss a student's thinking? Because
Okay,
I suppose
I think
part of
that's
that
great.
process.
What are the risks of not recognizing these different ways of expressing mathematical thinking, and porridge words, for instance? What are the risks if we just say, no, that's not right, this is the correct way of saying it? Is that a problem?
Edit, yes, thanks. Uh, I think there is an issue of either dismissing or moving too quickly and not recognizing what a child has actually shared when they are communicating their mathematical thinking. One, there could be a risk that the child may not want to share in the future. And that's actually really problematic because we do want dialogical classrooms. We want children to be able to share and feel confident and comfortable in sharing their mathematical thinking. So if we also dismiss, we can sometimes shut down that thinking process. So when a child is actually sharing their ideas and how they got to a particular solution or used a particular strategy, if we interrupt or we stop or try and recorrect, we run the risk of shutting down that child's thinking and sending that message to the child that their thinking is not valued, and so which may have that undesired implication of, once again, children not wanting to share their thinking. When we also rush through, we can sometimes reinforce incorrect mathematical language. So sometimes if we don't address it in that spot, we can reinforce incorrect mathematical language, like the example that I used with the naming of the angle and using circly bit instead of vertex. Um, when we're quick to rush in and fix and help a student, we might actually fix the word, but we might miss the underlying meaning of that word. So a child might actually have the conceptual understanding or understanding of the procedure that they're using, but when sometimes we rush through or overlook or something, we might actually miss what the child actually knows. So I suppose, yes, fixing the word is important, but listening and deeply listening to a child helps us understand why they're using that word, what imprecise language they're using, and then we can direct. So sometimes saying, well, you use circular bit when you should have used vertex. So it then goes, well, you've overlooked about why they're using that word.
I think you have inadvertently touched on yet again something else that has come up with almost every guest that I've had the pleasure of speaking to, which is the importance in teaching, particularly at primary, I think, of relationships and knowing the pupils, and being able to use that context to help understand what the next step might be or what the right approach might be for that pupil, which can be really hard when you've got 30 children in a class or 33 children in a class, or if you're part-time and you only see those children 2 days a week and things. But I think any time that you can use an opportunity to really get to know them, spend a little bit of time, and then begin to use that individual context to apply these principles is really important, isn't it? And can make a huge difference to individual children's experiences of maths. Kate, thank you so much for your time this morning, this evening. I really appreciate it. I know the listeners will have taken lots from the conversation. If people want to find out more about your work or yourself, where might be a good place for them to take a look?
I think we connected through LinkedIn. I've got an active profile on LinkedIn, so Kate Quane. I think there's 2 of us out there in the world. I'm the math education researcher one. Not the Irish person who does something else. So you can connect me through LinkedIn. If not, you can just contact me through email. Happy to respond to queries through email. Happy to share that email with you as well. I think they're probably the 2 channels that will be the easiest.
Fantastic. Thank you very much. Kate, thank you. Enjoy your evening. We'll be back on Friday with another Aftermaths episode where myself and Becky will pick apart some of the conversations that myself and Kate have had this morning. In the meantime, if you do have any questions or anything that you would like to add to this conversation, please do get in touch. You can get in touch with myself, primarymathspodcast@twinkle.co.uk. And otherwise, we will see you on Friday for another Aftermaths episode. Kate, once again, thank you so much for your time. It's been a pleasure having you on the show.
Thanks for the opportunity.